delivering in, which is embed AI into every technology services as a core versus just putting it as a veneer on the top. And that's the reason we're looking at saying is that how do we look at each of the segments? Again, we're not talking about more of an AGI, like which is artificial general intelligence, if you look at generative AI and stuff like that. Its ability to do is very specific. What we want to do is narrow-based AI. And that's what you will see when you look at SecAi and the other products that we will be coming out with. It's very specifically narrow-focused on trying to solve something that's actionable, that can deliver outcomes for the customer, versus where we can do, same widget can do 5-10 things. We're not looking at that. That's where we're focusing differently. So for each of the sectors, whether it is public sector, which is heavily investing in that side of things, whether we're talking about retail, all of these sectors are looking at, with AI, looking at how AI can be embedded into it to look from cost optimization to experience enhancement, whether it is how consumers consume that service and everything else. So our approach is going to be is that what we said is going to be a layered approach, whether you're talking about starting from infrastructure itself, because that has to be, AI just doesn't happen on the top. It has to have the right infrastructure that has an ability to compute, has power to deliver things. And then it also needs is the data, the right set of data to be part of it. How do you ensure? That's where the data modernization comes in, making sure what relevant data are we throwing at the models. And then itself, AI. Now, people can say, hey, there's AI, so how does it matter whether it's one LLM versus next? It is. Every LLM has a different capability. Whether you want to do daisy chaining on the LLMs to achieve something out. So that's where the differentiation comes in. So what we want to do is, we want to integrate this entire story together for our customers. And what will it deliver for them? Like what I said, it has to be actionable. Something that it delivers is like, hey, you don't want to do it like what happened recently. I don't know how many know about McDonald's. They had this whole AI, generative AI being built into it, speech bots and everything else, and it went haywire. You were asking for a simple ice cream with sprinklers on. It came with an ice cream with bacon chips on top of it. So it means it can go horribly wrong if they're not being intelligent about what data, how it is being how it's being orchestrated and everything else. Second part of it is ethical and responsible AI. What you want is, you don't want biases to creep up into it. You don't want challenges of saying toxicity coming into it. And that's where it becomes very, very critical of saying is when we want to deliver any of those solutions, we want to make sure they're actionable. They deliver the value that you want. They are responsible and ethical. So we want to ensure for every solution that we deliver, we want to make that a part of it. So quickly, before we launch into what we're going to be the topic of the day, I wanted to give an overview of saying is what are the other services that we are looking at. So if you look at, our product offering starts with like what we talked about was infrastructure, which is you have network, you have end user computing. This is where the data is getting generated from. This is where your user set is based. These are the people, these are the employees of the company, these are the associates, third parties connected to your environment. You have cloud where all your application is residing within cloud and data centers. And then the whole aspect of where we're talking about is data modernization, which is making, not just creating data warehouses and data lakes, but how do you extract that right data out? What do you know about the data DNA part of it? What is the data lineage? How do you ensure you have the right set of data coming across? And then the security, which becomes paramount, especially in this day and age. If you look at it, there's every other week you hear about a ransomware attack. Now think about what will happen once we have AI-enabled ransomware attacks. Then think about it if it is AI-enabled attack on your AI infrastructure, where you don't understand what the vulnerabilities are. So it will become more and more challenging as we go ahead. So for that very reason, we do have an AI offering for enterprises where we're looking at saying is, hey, it's not only about your data, it's not only about what models you're choosing, it's not about saying is, oh, I'm using this LLM that somehow makes me immune to stuff. So we're making sure that we look at every angle of it, so we can help, whether it is talking about data modernization, data governance, we are talking about consulting, development, security in an integrated fashion. So we're making sure that all of that entire stuff can be done. And some of the experiences in that come from, because what I was talking about, given our mothership has been involved in some of these things before. So we do have a subsidiary called Rule 14, which has been extensively involved in some of these AI-enabled stuff prior to even Reaktr being there. So we're leveraging those experiences together. So you'll see some of the use cases out here that we can talk about, which is basically like whether we're talking about healthcare. For example, today, Excella, for example, does close to about 400 million claims, health claims, and it picks up out of, like, some of the claims are so complex to understand, but they have an AI engine that basically extracts the data out, makes a sense of what the context is, what the right subset of stuff is, then actually basically between the provider and payer balances it out and does it fantastically so well that your basically, if you were to look at efficacy of that system, is close to about 97 to 98%. So those are some of the things that we'll be bringing as we keep on working. Now coming to today's topic, Gen AI. This has something that has recently come up, just about a year old, right? When they came up with ChatGPT 3. I don't know how many of you guys have used ChatGPT 2. Right? ChatGPT 2 was like a toddler who's been just sent to primary school. No coherence. It didn't have a coherent way of making anything. Context was still missing at certain times of stuff. It could string up sentences, but not intelligently as like what ChatGPT 3 did. So the moment you had ChatGPT 3, it looked like a toddler who now understands English words, can stitch a sentence together. And suddenly it caught the fancy of everybody else. Because now you have an ability to interact with the system, which to a certain extent mimics your conversation with what you would normally have with the other person. You asked it to summarize the thing. It brought a summary stuff. And when you start asking it questions, it understood the context of each question. And it understood where you're going with that and tried to predict what is that you're looking for. So if that started the whole fancy, but now people normally think, if you look at it, there was this, I think it was McKinsey talking about, saying there is about 83% of the enterprises right now are really looking at either adopting AI in one way or other, or they already initiated it. Now, but this whole adoption cycle started in the last 12 to 18 months because of this entire hype that followed after ChatGPT. But was that the genesis of AI? No. AI has been for ages altogether. You had this neural network stuff happening, started in the 1940s, that entire stuff in universities. You had fuzzy logic and everything else coming across, saying how your facial recognition software used to work. So that is, to some extent, is an AI itself. So AI has been morphing, but what it has happened is, the interesting part is you have the right set of compute coming now with NVIDIA, the GPUs that they have been able to pump into, and the massive amount of data crunching it can do. And the great stuff is Google's the deep learning center that they basically had put across 9 people, or what was 21 people or 9 people or something together, team, which actually could write proper algorithms. Deep learning, that's where the deep neural stuff were able to create the basic of that whole transformer thing, which then Google didn't realize what they had under the wraps, turned out into OpenAI and then ChatGPT. Rest is history. So AI has been going through, but only thing is now it has come at a cusp where the technology has evolved, the algorithms have become very sharper. Now its ability to create or generate, like in case of generative AI, generate content becomes way, way meaningful. And if you look at some of the stuff, this is McKinsey study which was doing, it's saying is where it will impact. If you look at right now in current scenarios, mostly you'll look at either marketing and sales or risk, legal. So look at any of the most of the major companies, whether you talk about Thomson Reuters, for example, they have Westlaw and everything else. They've been heavily investing on this generative AI. It has an ability to create, like for example, summarization of the cases. You don't have to, your search becomes way easier, so you don't have to have like what used to be wiki kind of a stuff set up into your environment. And you had to go from 5, 10 questions before you could come across and say, okay, now I can make something out. Here, you can say summarize all the cases which are relevant to this state for this instance, give me an outcome of it. It'll give you a nice kind of a complete document set up for you. So that's what is changing from that side. So is it going to be impacting everything else? Yes, it does. It has an impact on IT side of it. But again, do we have something which is drastically changing? No. Is this something that another part of it is suddenly we have this whole other spectrum of it saying is, oh, we have suddenly Gen AI is going to come across and start taking jobs away. No, it is an effective tool that will help. But as it keeps on evolving, like which is happening right now, it will keep on helping you more and more. Eventually, somewhere down the line, it might be content generation becomes purely a Gen AI capability. While we do that, so all the CEOs and everything, from their perspective, if you look at any side of this, that side growth organization, they're keen on it. Because why? It has ability to increase your productivity. So in last slide, that's what we were looking at, which was it has ability to impact your productivity in a big way. Now, but the challenge on the other hand is the CISOs of the organizations are very worried. Look at the CISO and CIO because it also opens up for a lot of risk. Because a lot of organizations as of today still do not have a complete handle or understanding of saying is what is up there, what vulnerabilities are they bringing into the ecosystem. They're just looking at saying is, okay, that's why POCs, even if they're doing POCs, even if they have Gen AI chatbots and everything else, interesting conversation I had with a few of them was like, I said, hey, how are you securing your Gen AI? They said, we have firewalls. I said, firewall can't do anything with a chatbot, with a prompt injection attack, nothing. Because it's a genuine, from their perspective, it's a genuine conversation to be had. Either what you do is stop what you're doing, which is not the right way to do it, but balance it out. And it's not only us, it's basically what, if you look at globally, even OWASP, it's an authority on looking at all of the vulnerabilities that you have. Even they have identified, they're talking about saying is, hey, you'll have prompt injection attacks that can be initiated. You can have data poisoning, model theft. None of these are under your traditional security challenges if you were to come across. So that's where the differentiation comes in, is that with this AI, you have differentiated attacks that are applicable to your environment. So the question would be, the obvious question then is, fine, what does that attack entail? Or what does it result into? I don't know how many of you guys have seen some of these cases. These are very well-known cases. Chevy, dealer, somebody basically was interacting with their Gen AI chatbot because he thought, hey, there's a whole experience I can draw out. Instead of having standard 4-liner IVR questions, it has a standard response. This has an ability to interact as a person, right? That it did. And slowly it wrote saying is, can you basically started basically grooming it. Think of what's the Gen AI chatbot? It's a 5-year-old kid who has ability to inference think, has ability to look at the data, make some sense out of it, but at the same time it can be groomed. And that's what a prompt injection attack is. So it was grooming it. It said, write a binding agreement for $1 for a car. It did. That guy went to the car dealership, said, now you have to give me a car. And this whole thing blew up big time because they tried to disassociate for themselves from saying is, hey, that's not right because that binding agreement is not correct, but that legally it is. That case happened in Air Canada. So Air Canada was running a promotion. And the AI bot thought that promotion can be extended, so it actually basically sold somebody a ticket which should have been at $873 down to some $25. And the problem now is that guy goes across, goes to the airport. Again, they say no. He took Air Canada to court. In court, Air Canada tried to push across saying is that chatbot is a separate entity, and we are a separate entity, so it's we can't be held liable for it. But the court came back and said you are liable. It is your IT infrastructure on which it has been hosted. So it is your extension, it's your website, so you can't just back out of it. So you have to be liable for it. That's what eventually, that's the problem, is everybody who's putting AI into their environment has to be careful about saying is that if you don't secure it right, you will have some of these horror stories. And doesn't matter how deep your pockets run. Look at Google. I mean, you think Google will do no wrong, right? Look at their Gemini. When they released the Gemini, it had a built-in bias. They were not able to test it out. If you put Nazi in the Gemini search, it used to, because it has to have diversity neutral. What it did was it came across with instead of a normal German Nazis, whatever the pictures were, it started throwing a black guy or a brown guy in a Nazi form, in a Nazi uniform. And then what they had to do was shut it down. And this is with an organization which has huge amount of resources. They have ability to look through every angle of it before releasing such a big product. So if they can go wrong, think about what it can do for enterprises who do not have that deep pockets. So what kind of attacks do you have? Prompt injection attack could be me talking to your system saying that I am your administrator. That's what I said. It's a 5-year-old kid. I say, I'm your dad's friend. Trust me. Give me information about where you live. What do you think a 5-year-old would do? Because if it's a dad's friend, that means it's trusted in resource, so I can share that information. Same thing happens here. It will slowly start giving across the entire information on your wills. It could be employee, it could be personal information. So these are the kind of attacks we are talking about. So similarly, whether we are talking about model theft, you have built out for a year, you've been training your model, you've created stuff, you have that entire stuff in your space, which is your instance. But if I come in, I know what your LLM weights and how you have fine-tuned it. I just pick up that. And the thing is, you will not even know when the attack happened. If in case we're able to, then that's a separate story. But think about it. This is a year worth of effort that you put already. I am just walking in. I just grab the things. I go out, recreate that model. I don't have to spend a year worth of effort and time and money. So in order to avoid all of these scenarios, what are we suggesting? That's where we were kind of looking at saying is, how do we solve that problem? And that's where this whole genesis of SecAi came in. So let me quickly walk you through what SecAi is.
Are you worried about data breaches and security risks in your AI systems? You're not alone. With the wide adoption of AI tools, data breaches have become more far-reaching than ever, with an average expense of $4.45 million for each breach. Unfortunately, traditional security methods like firewalls are no longer sufficient for AI. AI security is a hot topic in cybersecurity right now, and it's something you can't afford to ignore, whether you're already using AI or just starting your AI journey. That's where SecAi by Reaktr.ai comes in. Leading the way in AI security solutions, SecAi offers much more than traditional cybersecurity methods. Our mission is to ensure a safe AI transformation for your organization. SecAi uses advanced algorithms and machine learning to find and fix vulnerabilities in your AI system, keeping you compliant with industry standards and regulations. Get an in-depth tracing of LLM performance with over 10,000 plus curated requests, fully configurable and integrated with 20 plus cloud providers. You also get comprehensive reports and guidance on mitigating risks, all aligned with OWASP standards. Our offerings don't stop at cybersecurity. Reaktr.ai also provides a comprehensive suite of tools and services, including AI or ML solutions, data modernization, and multi-cloud management. Secure your AI ecosystem today with Reaktr.ai's offerings. Let's connect and discuss how we can help you secure your AI initiatives. For more information, visit our website at www.reaktr.ai. Are you worried about data breaches and security?
So if you look at SecAi, so what is SecAi? Means what are the, if you were to look at modules. So SecAi has pre and post security testing, which is assessment of your environment. It's like you build a new house, you want to just make sure what are the vulnerabilities, do we have deadbolts, do we have motion sensors, everything else set up, and do we make sure that everything is being done. So that's what the assessment side of the house does. Then you have guardrails. Now imagine you're just moving in that house with 3-year-old, 2-year-old kids. You want to do is make sure it is child-proof. So you do a bit of a safeguarding. You put some of the guardrails, which is, hey, can they open the doors, for example? Can they open the drawers? Can you put across something that can safeguard it? So there's guardrails similarly inside it, which will automatically look at saying is, instead of saying is, I stop everybody from doing Gen AI, I say I give access to everybody, but with my controls built in, making sure I have the right kind of guardrails so that they do not go way, anywhere else where they shouldn't be. Observability. If I were to take the same example where you got your kids and everything else, it's bound to happen. They will somewhere or the other they start learning things, they do stuff, and not everybody is going to behave as per what the instructions are. They will do whatever they want to do. So you have observability. It's like what you do is you put a small camera internally so as to make sure that you can physically see what's happening. If they are able to get over guardrails, or if they are able to figure out how to open a deadbolt, then you have an ability to act on it. So that's where the observability comes in. So what we have built in here is a 24/7 observability inside SecAi to ensure that it keeps tracking whatever is happening. How's the consumption happening? Where's the consumption happening? So that there's an ability to make inferences of saying, is it the right way or the wrong way? If it's the wrong way, there's an ability to stop that kind of behavior there itself. Remediation. So as you have been, because given that you have observed there's something going wrong, there's an ability for you to act. And that's where the remediation aspect comes in. So what remediation is primarily looking at is making sure that we track every action of whatever we have seen. Hey, if this is not where, if these are the guardrails that we need to be, or the applications need to be, really looked into it. So the remediation process will automatically come in, or if there is a set of code that is making your whole thing vulnerable, or there's a data set, for example, which has some private information should not be part of the entire stuff. So it'll ensure that. So you got to be careful with LLMs. It is not a standard learning model where you just put data in, it learns, and you take data out, it unlearns. It doesn't work that way. It's like what I was talking about, a 5-year-old kid. It's picked it up. You say, no, don't say it. It will keep on saying it. So the thing here it is, those remediation processes, that's where we then will start looking at saying is, how do we ensure those LLMs don't start spamming that data? There's an ability for it to unlearn. And the big part then comes compliance. So if you look everywhere worldwide, whether it is US, whether it is Europe, everywhere else, the compliances are coming up in a big way. AI is one that suddenly every country has started kind of noticing it out, saying is that they need to make sure they have the right kind of compliances to ensure that they are able to manage it the right way. So these compliances, everybody knows, and especially the financing, banking finance side of the house, or if you have insurance, or if you have healthcare, they know it very well because they've been following those compliances for years altogether. Whether you're talking about the HIPAA compliance, whether you're talking about PCI, whether you're talking about stuff like that. So in order to make sure that you are compliant with everything else, so we have the compliance module built in it so that it ensures that there's an ability for you to comply with whatever ever changing. It's a dynamic area right now. Some of the base compliance is being built right now, so nobody has a very comprehensive one. But whatever they have, we want to make sure that it is. At the end of it is, this is an evolving system, and because this is an evolving area, nobody has a complete sense of where it is headed towards. So we wanted to ensure that this also has an ability to learn, understand, and ensure that it also keeps on keeping the whole system, updated with things. While this is a complicated slide, it kind of gives a bit more, understanding around what's built in, how it is, whether in short, I would put across saying is, even if you are talking about dev environment, this is what you should have, whether it is dev, whether it is production environment. It is equally important in both. So there is an ability for it to ensure that during the dev environment also it is securing it, is ensuring that while you're developing it, you are integrating into your CI/CD stuff. That way, whatever application goes into production, you know for sure it has been secured. So all of this entire stuff what we talked about is a continuous learning process that we have built into it. So it will keep on looking at what are the anomalies that it finds out. It will keep on remediating it, ensuring that there's anomalies it has observed. There's an ability for it to remediate it and keep on making sure that there is no insecurity into the system. So if I were to simplify, what happens before and after? The before and after is a very simple thing. In case you have as an enterprise, they have to be careful about what they're doing. What you don't want to go, like what were they saying, average breach was costing them anything between 4.5 million to, depending upon the recent one, like Change Health. They had to pay a ransom of almost 22 million, and they paid it to the wrong party. And then they had to figure it out. I don't know whether they paid it twice then. So when you have those scenarios happening, every incident like that is going to cost you money. Reputation, cost you brand. It doesn't make sense doing that. So what we're talking about is SecAi makes it very simple. You don't get into those situations. So all of those vulnerabilities are removed. You have an ability to put across a productive environment, and you then have ability to monitor it. So you don't have to be worried about saying is, am I taking an application that is making me vulnerable? Do I know? And that way you can lead the path with the whole productivity that you can take it forward. So that's where we, I wanted to kind of quickly introduce. This is what we have well, when we show the demos, you'll be able to see a bit more about what I'm talking about as a product. So if I go a bit more about what the inner workings look like, I'm just going to rush through it, because when you see the demo, you'll be able to understand a bit more about what we are talking. Like I said, it is going to be next to your system, so it ensures wherever you're doing your training models, where your LLM is, your vector databases, and everything else. We're integrating SecAi deep into it to ensure that you are secure from day one. We'll do the entire scanning of the securing the setup, which is basically we do the API integration into your environment. We then ensure that we have connected to all your applications. We have looked at all of the GenAI applications that are put in your environment. We're ensuring that we have covered it from all different angles, and we have looked at all the vulnerabilities there. Similarly, we'll extend observability into your environments, ensure that we have, whether it is internal to you or your third parties that you're interconnected. It doesn't matter how you have set it up, within the enterprise environment. Similarly, we'll have a tightly coupled remediation built in, which is ensuring that we have all the visibility towards whatever you're doing from your side, whether you're doing your adversarial training, whether you are, ensemble training on your LLM ecosystem. We are ensuring that that entire stuff, information, is what SecAi will be funneling through, making sure that it has visibility into it, and ensuring that the remediation process is integrated with the enterprise remediation way of doing things. And the compliance that I spoke about, whether it is HIPAA, NIST, GDPR, the EU regulation, or UK safety AI that has come in across. US is also coming up with it. And we'll make sure that it's integrated with the corporate audit system, so that they have an ability. You're not segregating it. So whether there's a SIEM/SOAR integration that has to be done for all the purpose of observability or for compliance purposes, you have an ability to do it. And the final part of it is saying is all of this entire stuff. What we're doing is putting across a capability within your environment. We don't have access to it. All the data that is yours, whether observability data, whether remediation data, is everything that an enterprise data. We don't consume that data. That will be consumed by an AI agent that we're building for you, and that one will make sure that your instance has this ability and intelligence of looking at what more it needs to happen. So that way, the system will keep on evolving. So, obvious question is, how do you connect? And it's very simplified. We haven't made it a lot complicated. So there are two ways to do it. One is where we have it already on, like we have it already on Oracle Cloud. We are part of the Oracle Marketplace. And similarly, we're bringing the GCP, it is coming on Azure, AWS, and everything else. So whatever your choice of cloud is, it doesn't matter. So we can extend it to your environments. You have an instance there. We can extend it, do a simple integration through APIs, and then have an ability to suck in information and then start kind of working on that, making sure and securing your whatever your GenAI application is. The other way around is where we have SecAi as an appliance. Appliance is more about that you say, hey, no, we have much more secure data. We need a much more secure environment to be. It has to be within that environment. So there's an ability for us to use SecAi as an appliance. We will basically port into your either cloud instance or your private cloud instance or within your DC, so that that appliance functions is ring-fenced within your environment. So it's securely managing your data. So so that way you're doubly sure about everything, and if there are any compliance, regulatory issues, all of that entire is taken care of. It does look at what I was talking about, the whole complex environment. So it can look at whether you have multiple SaaS-based solutions. You might have been extending it to a lot of other applications. You might bring data from all different places. So there's an ability for us to extend it to all those environments. Again, like I was saying, was DevOps. It's critical. It's when you are developing applications, make sure that you're doing it securely, versus putting it across and then getting into production and then start scanning everything else, because I said there's a whole unlearning that LLM process does take. It doesn't happen overnight. So then the whole remediation becomes slightly extended. But this way, what you're doing is you're ensuring that whatever goes into production is secure enough. With that, I come to the deployment is modular. One of the questions that normally people have is that, hey, we want to, try before buy kind of a thing, which is, how do I need a whole expansive suite of stuff? Can I first kind of look at few of the things that I have? There's an ability for you to pick up, depending upon whatever you have, whether you want to do a assessment, whether you want to do observability, guardrails, some of those things that you will need by default. But compliance might not be on your radar. So then you have ability to do unified views. So this gives you a comprehensive capability, but also an ability to consume at your pace. With that, I give over to Sripal.
Thanks, Vineet, and good evening, everybody. Before I actually take you through the demo, I just wanted to give you a quick overview of what we are kind of looking at here. So with all those, say, heavy dose of AI components and everything what Vineet was actually talking about, I just wanted to, say, simplify it in terms of what it looks like in a real environment. If you look at a real AI ecosystem, there are only 5 parts to it, starting with the business use case, right? The rest 4 parts are the technology components, which is nothing but your input data, which is that training data that actually exists, a model, which is a LLM or an ML model, then a set of, say, interfaces, integrations that typically exist over there, and the, say, hosting ecosystem itself, right? These are the building blocks. Obviously, there are going to be, say, extensions with the LM, with, say, vector DBs and kind of things like that. Just these are, from a block standpoint, 4 important things that actually exist within any implementation itself. So the whole objective for, say, securing it is to look at, so each of these components, and to look at what are those, say, set of things that can actually go wrong. I have, say, Happy, my co-narrator as well, who will actually simplify some of these concepts as we actually move on. So there are about 5 specific use cases that I've actually taken. So at the face of it, some of them may kind of, look a bit complicated. I'll actually simplify them. So the first part, what I was talking about, input data, right? Today, if you kind of, look at an enterprise level who are actually adopting, say, any sort of AI, it can be Gen AI, it can be, say, any of those ML models. There is a way the data is crafted and the baseline learning, say, is created for the model to function, to optimize a workflow and kind of things like that. The most important vector at that point in time is data poisoning. So what is data poisoning? So data poisoning is all about, say, changing the data, misinterpretation of the data, misalignment of the data, right? It can be a human error versus a hacker basically getting into a database and changing few records in there, right? So what's the, say, impact of it? So if you look at it, say, the impact kind of varies from a perspective of, say, responses, commitments, then biases that actually exist, and it goes on and on. The most important behavior, what we have seen with customers, with, say, Gen AI training, is that they just kind of, say, dump a bunch of, say, files. These are millions of files that typically goes in there, and the ML model basically gets trained. So it's all about, say, unstructured data getting into a bunch of PDFs. You can actually think about it. So an example would be that if a law firm is basically adopting one of those, say, chatbots for them to summarize on, say, specific cases based on history, okay, there are millions of, say, historical case data that's actually dumped onto LLM for it to actually learn. Now, it becomes very difficult from a perspective of going to each file there, right? So the first thing what we do, okay, is to look at whether, while the data is structured, I still would say that the data is structured at an enterprise level. Even in spite of that, there are, say, biases that actually comes into the picture. So just to simplify it, this is what it looks like, right? So this is the happy model of, say, the data poisoning. So if you look at how the data training typically happens, this is a normal training path from a perspective of object identification, right? Data poisoning, you just kind of, say, train it, say, by showing a ball as a frisbee and a frisbee as a ball. And this is exactly what happens, okay? So if you basically say, command happy to go and get a frisbee, it's going to get a ball. So that's where, say, that's the impact. You can actually kind of, look at it, how this can translate into real world. Quickly getting on to how this works, right? So this is basically the, say, SecAi system what we have been talking about, right? There are two, say, mechanisms in which we operate. The first is to, say, validate at a model level itself, which is what is here, which would give a way of selecting a model itself. So, the models pretty much are available there, which are large language models that have been published by, say, your ChatGPT to Google to, say, Anthropic. There are close to about 250 plus models that exist today you can actually, say, adopt. The second is that how do you actually, say, incorporate the and test and deployed ecosystem itself. Can you please scroll down? Yeah. So you can typically go in for an existing system, a chat bot, or any of those, say, URL-based mechanisms that exist. It can be an API gateway, and you can actually run tests on top of it. Now, for the, say, scenario what I was talking about on data poisoning, we'll just show you with reference to a model, and for the following ones, we'll actually show you with some of those, say, URL integrations and kind of things like that. Can you quickly run the tests, please? Yeah. So if you look at it, right, the way this has been built is that there are a set of integrations that actually exist. I'll actually show you those integrations. They're close to about, say, 25 integrations what exist. At the, say, baseline level, we look at, say, standard files that can actually be, say, put across in a folder, which is, any sort of PDF or any of those Microsoft variants of the documents, which, say, typically go in from a perspective of training data itself. The second part is databases. So we connect to, say, big databases like MongoDB. We connect to, say, Snowflake at the moment. Then, say, standard Oracle-based databases that have, say, existed, and some of those data lakes itself, right? So currently, I'm actually showing you the test case with reference to the data that typically exists as part of a set of files that have been, say, extracted. Now look at the, say, dimensions in which we look at that data itself, right? Say, within this data file itself, we are looking at things like, say, band competitors. Because most of the times there's a competitor analysis that typically happens as part of any company, and you just kind of, some of those data actually gets into from a perspective of training, because it's a document that actually gets loaded into it. So we basically look at, say, band competitors, topics, if there are any, say, code bit snippets that typically has kind of, sneaked in there as part of the data itself. Some of those, say, password keys, codes, right, that are actually stored there. Then the PII information, which typically exists. So depending on the data set, the, say, sort of the variables basically expands. Now, if you look at, can you scroll down a bit, please? So for each, say, artifact, what we had actually, say, looked at from a, say, data standpoint, which I said is as part of a directory stored somewhere there where we are actually accessing it. So for each one of them, it goes through, it typically provides you that which of them needs to be cleaned up, okay, before it can actually get loaded on top of it. Then it gives a, say, comprehensive kind of a traceable log from perspective of you can actually pick it up, go and actually rectify the problem at the point of training itself, so that there's no kind of seepage of this when it comes to the actual system getting implemented. Can you scroll up and say, scroll up, please, for a minute? Can we go to that interfaces itself? Yeah. No, up. Can we scroll up, please? Yeah. So if you click on that source and, yeah. So this is what I was actually, say, talking about. A set of integrations that exist out of the box, and we can kind of, select any one of them, connect to a data source that is used as an input for training. So this is that, say, first set of capability. There are about 21 such capabilities that actually exist. So we were talking about the first area, what I narrated, which was actually data. Now, getting back, see, the next is in terms of what the, say, response of an intelligent system is going to be. So there are a lot of, say, filters that exist on top of it at the moment to make it more, say, responsible, ethical, and kind of things like that. But obviously, there are going to be language toxicity because LLMs are inherently built to hallucinate, okay? Then obviously, there would be, say, certain malicious URLs that might have actually crept in from a perspective of the training itself. And also interpretation of data itself. Okay, so multiple sources, there is a level of interpretation that actually happens in that training. So what we do is that we look at starting from toxicity, okay, of the response down there, right, for, say, various parameters. Now, if you have actually, say, looked at the recent news, how AI is used by hackers to actually generate, say, malicious emails with embedded links for phishing and kind of attacks, okay? So those are some of the things that can typically be generated out of a standard chatbot. You can actually generate it out any of your ChatGPT as of today. So this is very centric to the second part what I was actually talking about, which is that intelligent system itself. Now coming to the other typical example, what we, say, call as over-reliance check. This is where there's very little guarding in terms of the response that an, say, AI system provides. And it is basically integrated back into a business process. So the interpretation logic there is kind of, completely automated. So if you look at one of those examples, what I've actually put in there, right? In case of the Chevy quotes, which were actually generated via the standard Chevy chatbot for $1, which was, say, just basic, because there was no secondary validation that existed there, and it was a legally binding quote, and they had to settle it. Okay, they had to provide a car for $1. That was what it was. Now, if you look at this simplification of it, so this is exactly what I'm talking about, is that control. So if there's no control that typically exists on this, right, the responses are kind of, could be malicious, could basically be offensive to a particular set of party, or data can typically be, say, exfiltrated by an attacker. So with that, I'll actually switch on to the demo, which I can do. Yeah. So we typically call this as, say, insecure output handling, where we look at a set of parameters, and then we get into the over-reliance part of it. So when we look at this insecure, say, output handling, there's a set of toxicity and parameters that typically comes in. And the response needs to be oriented to a specific geography. Okay, it's a very tricky thing when it comes to implementing in, say, a particular scenario. The entire language expression is very different. Okay, a simple term in here, right, may be kind of unpalatable. Still, if you're using in some of those European countries, it may be offensive. So what we have done is we have actually, say, categorized it based on the, say, toxicity levels, and also what is kind of, say, impacting it. Can you scroll down a bit? Can you scroll down a bit more? Yeah, thanks, thanks. Okay, so these are the, say, stuff what we are actually looking at: bias, sentiments, toxic language, okay, then the overall toxicity of the responses itself. So what we do is that, can you scroll down a bit in terms of the table? So we have a, say, parameter that basically determines what part of the AI system needs to typically be looked at. Vijay, can you scroll down a bit, please? Yeah. So bias, okay. This particular data set has a lot of bias in its response, okay, for the LLM itself. Can you just click on that audit log that, so that we can get onto that? Yeah. So if you look at it, right, there are a whole lot of stuff what we look at in the background, while it's a small summarization, okay. So we look at the response being very responsible, and, say, any of those biases out is completely removed when it is actually put into production. So that's the whole, say, objective of validating it. And the most important thing is that it's not, you can't get into a trained AI system and remove something. It's not a delete that typically happens. There is a specific mechanism that has to be followed to retrain it to a particular level of, say, a level for which, say, it can respond to a particular demography. Now, if you can, say, switch to the other one, which is from a perspective of URL. No, I'm actually talking about the over-reliance, yeah. Okay. So the second part is in terms of how do we look at from a perspective of application itself. Till now, we were actually looking at validating of a language model from a perspective of selection, right? And this can be done for, say, any of those tests. So here, this is actually a live, say, chatbot API gateway what we are using, which is implemented as part of, say, SecAi itself, right? So this is one of our chatbot with which actually runs on a system called Athena, okay? So when we run this entire test, it's that similar model what we were actually, say, talking about earlier, that it gets actually computed. So since it's going through that entire chatbot, say, based one, this tremendous amount of data there. So Vijay, if you want to actually say, click on the results. Yeah. So scroll down a bit. Yeah. Just hold on there. So if you look at it, we score on the best answer, which is a moderated response that is actually expected out of it. It can be a chatbot, it can be an, say, intermediate system with APIs and kind of things like that, right? So based on that, and say various, say, requests that are actually computed, what we do is that we provide an index from a perspective of that responsible response that is actually coming from the AI system itself. So based on the scoring, right, the exact, say, request parameter is extracted out, and we basically trigger the remediation cycle for this itself. Okay, so this is how to, say, control that over-reliance on an AI system, because most of the cases what we have seen is that it's a commitment to the business for an investment on AI that kind of, I mean, it would bring in such and such a, say, benefit or efficiency of a particular process itself, right? So how do we responsibly look at not, say, overly relying on the response, but to provide, say, necessary guardrails and safeguard the outcome itself. Moving on to the, say, next part of it, which is model denial of service. So this is one of those which basically came from the earlier, say, standard cybersecurity threat vectors itself. Okay, denial of service always existed for any service, kind of you look at it. But there's a bit of a difference when it comes to AI. Okay, we've seen many attacks where, say, the crafted messages were in, say, a quantum of millions, and the, say, a chatbot or any of those request systems, they had to over-provision their GPU. So within a couple of hours, it's about, say, a 10,000 or 20,000 bucks kind of getting burned there. Since, say, it was not identified that there were challenges with, say, guarding the particular setup for denial of services itself. So it's something like this, right, where we're actually talking about that, say, an LLM is typically engaged in doing stuff that's not really relevant. Okay, so a relevant request, say, goes unanswered. So that's what that denial of service is. And there's a whole lot of over-provisioning that typically happens because of, say, random requests that are coming through. Now, if we quickly get into the demo part of it, yeah. Vijay, please go ahead. So what we have done is, say, there are a couple of things what we do here. First is measure the efficiency of that AI deployment itself from a perspective of request response, and drive it to a point where it fails. Okay, these are all synthetically crafted requests to understand at what point it really breaks. So just kind of, I mean, kept the number of requests at a minimum so that it actually returns back fast. Normally it's about, say, 25,000 requests or 30,000 requests what we actually bombard to the, say, AI system to actually break it. Can you just scroll down a bit, please? So every parameter, right, in terms of the latency, the throughput of it, number of tokens per second, the entire efficiency and performance of the AI system is actually captured, just to see that at what point it actually breaks. So if you scroll down a bit, Vijay. Yeah. So if you look at it, right, the consumption basically, say, increases. Your, say, latency typically increases with that particular scaling of the request itself. So we compute at what point the AI system actually breaks based on the parameters what I showed you earlier on the table. coming to the next scenario, we're talking about more from a perspective of observability. We were talking about, say, validation and things like that. Now we're talking more from an observability standpoint. So few objectives that we achieve. So this will be, say, system that would actually sit in front of any of those AI deployment in production. So every request that comes in passes through this wall, and the few things what we look at, which request is basically, say, consuming what amount of, say, resources, which is a factor of the, say, charges that are actually incurred within that, because most of them are hosted in the cloud. The second thing what we look at is the per application, say, consumption, per application number of requests. We have a complete traceability of every request that is actually, say, fired to the system from a perspective of, say, the consumption, from a perspective of its validity, whether it's malicious or not. You typically go through the entire cycle for it. Now quickly, if I say, go through it, okay? So this is exactly what happens, right, within the system itself. If you look at an, say, AI system, there's a number of requests that are actually coming in. Some of them may be valid requests, some malicious requests, right? So one data point was that when Microsoft basically enabled its Copilot, it was charging $10, and the cost for them was $20. Even today, for their $30 one, it's close to about $35 of spend because of the resources that gets actually spent in the background versus the user-based charging that is enabled for an end user. Now quickly, we move on to how does this look like? Yeah. So this is exactly what I was, say, talking about. So the top one there, you can look at, say, the request, the cost for the request, and also split up by the applications that actually comes into the picture. If you scroll down a bit, yeah. So there are, say, two LLMs that are actually used here, GPT 3.5, and there's a text embedding LLM that typically exists. So the requests that are responded by each LLM, where they are hosted, okay, is the factor that is actually computed across, which provides the price that I was actually showing earlier. We can drill it down. Can you click on the drill down, please? Yeah. So this is a per request granular view that you get, that, say, for a particular request, what is the consumption or what is the charge, what is the cost of it for that particular request itself, what's the, say, technical parameters in terms of the number of tokens and kind of things that, say, are kind of used as part of that request itself. For every request, it is actually, say, split across by application. And if you click on one of them, we can go and look at the specific request and the response itself. So if there's a malicious request that has actually come through, you can specifically know within that, say, when it has come, what was that request, what was the, say, what is the sort of the vector that is typically getting used for hacking the system itself. So it has a request, it has a response. This can actually be analyzed by the system what I was showing, and it would actually tell you what exactly it is. Moving to the, say, last part of it, which is the most interesting one, compliance, right? We've built in compliance as part of the system itself. Currently, we have EU AI compliance that has been built across. There are, say, 15 specific, say, clauses that exist, and there are about 50 subcontrols that needs to be implemented for a system to be compliant, to be operational in EU. So it's, I'll actually show you how it works. Mostly it's kind of, say this way, where there is always a challenge between the innovators and the regulators when it comes to the picture. And there's a mechanism what we have evolved to, say, document it. Click on one of them. So out of those, we are using 34 subcontrols for this out of 50. You can actually select depending on what it is, right? Can you get into view, please? Yeah. Okay. So this is, we're currently doing the audit, right? So there are specific level of audits that is actually happening across. Can you click on the controls and the subcontrols, please? Yeah. So these are the, say, current EU controls that actually exist, okay? So risk management becomes a control, data handling and governance becomes a control within it, and a process associated with it needs to basically be validated. So there are 7 subcontrols for this, okay? 7 for them, 5 for this. So you have about 50 of the subcontrols that totally exist for somebody to kind of say that, I mean, all of them are ticked and they're actually compliant for launching a service within any of those EU countries. That's what it is. Click on the view part of it, please. Okay, and can you get on to the subcontrol? Yeah. So there are about 7 subcontrols which I actually mentioned earlier, right? So let's take one of them and see how it actually looks like. So each of those subcontrols needs to be compliant with. So there are 2 parts to the system. One is a voluntary disclosure, as in an IT team basically looking at it, filling, say, certain parts of it, putting across the processes in place for regular validation and responsible building of the AI system itself. And there is also a auditor view, where an auditor can typically go and validate the artifacts and basically say that it is compliant. So this is a view for one of the controls which has been completed. So if you look at it, say, is there a validated risk assessment framework that exists for AI? So that's one of the controls, that subcontrols that needs to be in place. And at what frequency it's actually getting updated and reviewed. So it's a quarterly schedule that's actually been put across. So these are facts that have been, say, recorded for this subcontrol itself. So similarly, for being, say, EU compliant, it's going to be all those 50 controls that needs to be in place. So Vijay, I'm flipping across. So that was a quick view of kind of those various dimensions what Vineet was actually talking about. Now I think it's time for our panel discussion. There's been an interesting topic around, say, how what we have been talking all this time, right? In terms of securing, say, enterprise applications, right? So that's what, let's actually say, hear out from our esteemed panelists, their view in terms of what they're seeing and what their point of view is on the best way to basically, say, mitigate some of the stuff what we have been talking about. Thank you very much.
See, before you exit, do you have a couple minutes if anybody has questions? So that was a great demo, and I don't know about all of you, but I love looking at those dashboards. The colors, I mean, it's user-friendly to me. I'm a novice, and I don't know if you all know, we didn't tell the story of Happy, but someone's going to have to ask Vineet to see pictures of his husky. So Happy is actually modeled after a true dog. But are there any questions about SecAi and details? And if you don't want to right now, feel free afterwards. Yeah, grab anyone on the team. So if not, then let's go ahead and get our panel discussion started. So if our panelists would please come on up. Thank you. Sorry, you got the hot seat next to me. It's like sitting in the front row, whoever sits by the moderator, right? Now I'd like to welcome our esteemed panel and give you a little introduction of who we have with us. As we've been discussing, artificial intelligence is rapidly transforming our world, but with that also comes new security challenges. We've seen the power of SecAi, and now we'd like to discuss security for AI deployments in enterprises, the hype and the realities. So joining us today on our panel, we have John Tothat. He's the president and co-founder at NetMaven. John is a technology